In this chapter, we're going to learn about something called probability distributions. But to talk about them, we first need to talk about probability. I'd like to give you a very intuitive introduction to probability, and I'll keep this as simple as possible. Probability is a measure of the likelihood of an occurrence. For example, suppose you flip a coin. How would you describe the probability of getting heads? What about the probability of getting tails? Well, you have an equal chance of getting either one, so a typical way of saying the likelihood of getting either one is you have a 50-50 chance. And what we mean by that is you have a 50% chance or probability of getting a head, and similarly a 50% probability of getting tails. I'm going to introduce a little bit of mathematical notation here. A shorter way of saying probability of heads so that we don't have to write it out in words is we use a capital P, and then we'll use the letter H to represent heads. So this notation is read probability of heads. And we've just decided that that is 50%. Similarly, the probability of getting tails, I'm going to call that P of T, is also 50%. Now, although thinking about percentages is more intuitive for most of us, to do calculations, we're going to need to write our percents as decimals. Or if you prefer, you can write them as fractions when it's convenient to do that. So 50% we could write either as 0.50 or as 1/2. Let's look at another situation. Suppose you roll a die. Die, by the way, is the singular of dice. So you have one die, two dice. And it's a fair die, meaning it's not loaded. Now, a die has 6 sides. And each side is labeled with dots. And the number of dots ranges from 1 to 6. So if there's 1 dot, we're going to call that just the number 1. If there's 2 dots, we'll call that the number 2. 3 dots is the number 3, etc. So how would you describe the probability of rolling a 2? Well, the way we usually say that in words is you have a 1 in 6 chance. There's 6 sides. We're interested in one of them. They're all equally likely, therefore you have a 1 in 6 chance. A 1 in 6 chance is the same thing as saying you have a 1/6 probability. In other words, to use that handy notation we just introduced, probability of 2 is 1/6. And of course that can be written in decimal form as well. It's a repeating decimal, so we'll have to round it off. I'm going to round it off to 3 decimal places. How would you describe the probability of rolling an odd number? There are 3 sides that have odd numbers on them, 1, 3, and 5. So one way we would describe that in words is 3 chances in 6. In other words, 3/6 chance. Another way to look at that is to say, well, half of the numbers are odd, so I have a 50-50 chance of getting an odd number. In other words, I have a 1/2 probability of getting an odd number. And you can think about this either way because 3/6 is the same as 1/2. In fact, I would typically simplify 3/6 to 1/2 anyway. So we can write out that the probability of getting an odd number is 1/2, or if you prefer decimals, 0.50. Next, let's suppose you have a bag containing 3 yellow marbles, 3 blue marbles, and 1 red marble. So there's 7 marbles in the bag. If you take a marble totally at random out of the bag, what do you think the probability of getting a red marble is? So P of R. Well, there's 1 red marble out of the 7, so you have 1 chance in 7, which we can express as a 1/7 chance, or 1/7 probability. What do you think the probability of getting a yellow marble is? Well, there's 3 yellow marbles in the bag, so you have 3 chances out of 7. In other words, the probability is 3/7. I hope this is pretty much making sense. If not, always feel free to ask questions. But hopefully it is, so let's develop some vocabulary to help us talk about these things. First of all, a probability experiment is an action or process with an uncertain result. So in our marble example, the probability experiment is taking a marble out of the bag, and we don't know before we do that what color we're going to get. An outcome is a result of an experiment. So in our marble example, there were 3 possible outcomes: yellow, blue, and red. The sample space of an experiment is the collection of all possible outcomes. So that would be the collection of outcomes yellow, blue, red for us. Last, an event is any collection of 1 or more outcomes. So getting a red marble, that's an event, also an outcome. An event that would not be a simple outcome would be something like getting a yellow or a blue. So that's like 2 outcomes put together. That's an event.